Now the big difference between ratios and rates is what they're comparing. Ratios are comparisons of two quantities of objects where we have the same unit of measure. And there's three different ways typically that we can write a ratio. We could write a ratio as a fraction. So for example, 2 over 3. This is a ratio, 2 to 3. We could also write this as two numbers separated by a colon. For example, 2 to 3. And we read the colon as the word 2. And of course the third way is just to say it, and we could say the numbers with 2 in the middle. And we could also write it like this, 2 to 3. So all three of these ways are perfectly acceptable ways to describe a ratio of two quantities that have the same unit of measure. Let's say we have the comparison 14 to 2, and we want to write this comparison in all three different ways. The first way is using a fraction. So we could put the first number as the numerator, second number as the denominator, and try to get this into simplest form. Well, if we were to divide both of these numbers by 2, we get 7 over 1, which is the same thing as 7. Now I just want to make a point here that it's important for us to keep this one because we're going to use this when we write down the second and third ways to compare these numbers. So we could say that 14 to 2 is the same thing as 7 colon 1. Right, in other words, I take the numerator of this simplified fraction, write it first, the fraction bar becomes our colon, and the denominator becomes the number 1. And of course, the third way that we could write this comparison in simplest form is to say 7 to 1. Now, in addition to ratios, there are also comparisons that are called rates. And rates occur when we're trying to compare two quantities that have different units. And usually a rate can be separated from a ratio because we end up using the word per more often for a rate. One of the most common rates you may have seen if you drive a vehicle is a rate called kilometers per hour, or if you happen to be American, miles per hour. So since this is a Canadian-friendly video, we're going to ignore miles per hour just for a second and focus on kilometers per hour. And we're going to pretend maybe we're passing by a school in a school zone at 40 kilometers per hour. This is a special kind of rate. This is something called a unit rate, because the second quantity that we're comparing has only one unit associated with it. The first quantity has 40. We have 40 kilometers per 1 hour. So this is usually what we're striving for when we're looking at rates. We're looking at how many kilometers per hour am I driving? And we use that to answer the question, okay, if I go and drive for 5 hours, how many kilometers will I have driven? Or you might be at the grocery store and you buy a big bag of apples for $12 and there's 12 apples in there. You want to figure out how much are you paying per apple. In that case, it would be $1 per apple. So this is where unit rates are a bit advantageous for us. They help us kind of make comparisons or to ask the question, how far or how much will I have gone after X number of hours or X number of dollars? A really common question we might want to ask about unit rates regards money. So let's pretend we've made $45 over the span of 3 hours, and we're interested in how much money we made per hour. Well, the idea here is that we've made $45 per 3 hours. So we can think of this as a fraction, that's okay. And we could, if we needed to, divide 45 by 3 to get a unit rate, because what we're looking for in the denominator is dollars per 1 hour. And in fact, 45 does have a factor of 3, and if we divide 45 by 3, we get the number 15. So in other words, we've made $15 per hour. Once we have this unit rate, then it's really easy for us to go ahead and figure out how much we would make in the span of 6 or 7 hours. Okay, for example, let's say we want to figure out how much money we'd make in 6 hours. Well, we set this up as an equivalent fraction question. We know that we make $15 per 1 hour as one of our fractions, and what we're interested in doing is creating a denominator of 6 hours. And we notice that to move from 1 hour to 6 hours, we multiply by 6. So that must be true for our numerator as well. What is 15 times 6? Well, 15 times 6 is 90. So in the span of 6 hours, knowing that we make $15 per hour, we should get $90 if we work for 6 hours. All right, my little epsilons, stay positive.